solution. And my gas has similarities to Mark. It's a sulfur-containing gas as well. So it's dimethyl sulfide, or DMS. In low concentrations, it's attributed to the smell of the sea. And it's also beneficial to the marine environment. In the atmosphere, it has oxidation chemistry and helps make clouds more shiny, scatters sunlight back to space. But at high concentrations, it smells of cabbages, and I'm not a fan of cabbagey smells, so I don't like it.
My name's Dave Gorman. I'm not a scientist, but I'm here because I won a competition. And the gas I would least like to be in a room with is Jumping Jack Flash.
And this is our panel.
Now, Mark, you've written a book about gas.
It's called It's a Gas.
Why?
I just think gas is a form of matter that is really underappreciated. Like, it's mostly invisible. It mostly doesn't smell of anything, and you mostly just don't even notice it's there. It's kind of all around us. It's responsible for the birth of all the planets and all the universe, but it isn't appreciated enough. And it's in all our lives. In fact, it's our life support system. If you go to hospital, it's part of medicine. It's obviously part of the air we breathe. It keeps the climate and us alive in terms of all life on the planet. And also, and let's not forget this, it is responsible for the bicycle being as brilliant as it is. And bicycles are amazing, and they're amazing because of gas.
I object to you saying that gas is irresponsible for the birth of the universe.
I knew it. I was baiting you. I was.
I'm glad that Mark mentioned bicycles, though, because one of my favourite gigs I did was it was at the Royal Institution, where he decided he would enter by riding in on a penny farthing, but failed to check the height of the door before doing so. Dave, sometimes it's quite hard to get the guest in, and initially I thought getting in a kind of non-scientific guest on gas, it's going to be difficult, but I don't think it is. So, Dave, did you have a soda stream when you were a kid?
I did, actually, and I very much enjoyed a soda stream. I feel like this is a topic I've got input in. Like many people, I've got a young child, which means like many households, Gladiators, the reboot, has been really big in our house, and we had a conversation which I imagine millions of homes up and down the land have had, which is, what would your gladiator name be if you were a gladiator? And it was universally voted by my family that mine would be Wind.
Lucy, we should start with the definition. So what is a gas?
A gas is basically a material that has a lot of energy, so it likes to be separated from its other molecules, unlike solids or liquids. Although, having said that, if you take a cubic centimetre of air, you've got around 10 to the 19 molecules of gas in there. Because they're invisible, we can't see them, most of them don't smell either. But the essence of being a gas is you don't like your neighbours, really. You want to be separate from them and exist because you've got your own energy going on. You've got your own kinetic energy. So unlike in a solid and a liquid where the molecules are attracted to each other, so that's where they stay. So they're excitable creatures.
What's the difference between a vapour and a gas? Because we say vapour, don't we? So
we do say vapour. I feel like a vapour
is a cloud a gas?
I feel like a vapour is a sort of old-fashioned term for a gas. Or maybe it's a gas that you can see, so a cloudy, so something that is maybe has particles in there as well. So if you have maybe small water droplets, you'll be able to see them because they're going to scatter light.
But there is that thing about vapours that they are condensable, aren't they? So the reason why you can smell perfume is because a vapour comes off the liquid, but the liquid is still also a liquid. So where a gas and a liquid both inhabit the same space, that's what you're smelling as the vapour. Whereas these little particles of actual liquid, they're an aerosol, I think, aren't they? They are a liquid phase in the gas, in the air, as is a cloud. A cloud is these tiny droplets of water. And so when you look at the sky, the things you notice are these little droplets. The liquid phase, actually, you don't notice the gas phase. And again, why do we not appreciate this enormous volume of gas, 100 kilometres high, the atmosphere? And we're at the bottom of this sea of gas, and this is called atmospheric pressure. And it has shaped our history, it's shaped our evolution, but because we were born at the bottom of this sea of gas, we're used to it. And then we don't notice when it does strange things. But it is responsible for lots of our gas technologies, like the steam engine.
I can answer your question as to why it's underappreciated, though. It's because we can't see it, hear it, touch it, feel it, or smell it. So we don't know it's there. So, of course, it's underappreciated. It's invisible.
Sorry, Liz.
So I was going to say, Mark's comment about it being so thin, I mean, when you see the images of the atmosphere from space, and it looks just like this tiny, thin layer, it's, 100 kilometers thick, so you could drive out of it in an hour if it was horizontal, and yet it has all these amazing functions for us. So keeps us warm, protects us from UV radiation, gives us oxygen to breathe, all of these functions that we don't even realize because they're just happening around us and not visible.
Yeah, it does raise the question.
Can you hear a sound? There's a noise being picked up in OBS from my mic. And it's a cyclical noise. It's a rhythmic noise. And it happens if I turn my volume all the way down or disconnect my mic. So something's causing some kind of interference, and I can't think of what it would be. What I'm going to do is I'm going to make my mic mono, so it comes through more channels than just the right side, which I don't know why that's happening. I need to look at my audio interface. Anyway, can't do anything from here, so.
Discovered something that nobody's discovered for 23 centuries, because he discovered that in fact it was a composition, it wasn't some intangible, indestructible element of just air. I think he did experiments with mice, correct me if I'm wrong, so he maybe did some things that maybe not have met the scrutiny of today's
They all did those in those days. They were,
yes,
they did not fill in ethics forms at all.
No, they did not. They didn't do their health and safety, but I think he used to put upside-down beakers, and then I think with the thing with oxygen, there was a mouse in a jar with also a piece of wood. So if he discovered that whatever it is that made the flame happen, which was oxygen, also kept the mouse alive, and he did the control experiment where the mouse did not stay alive as well. But with that came the discovery of oxygen, and the air was not just some intangible thing, but actually had composition and was made up of lots of different elements.
So it burnt the wood to take the oxygen out of the jar?
Yes. Hence
and then noticed that the air was still there, but the mouse wasn't.
The mouse wasn't. Not in its living state, anyway. I mean, what an experiment.
I don't think that's proved that oxygen is a thing. I think that's proved he's barbecued a mouse.
Well, I don't think he set the mouse on fire, did he? It was separate from the flame.
Then he wasted the mouse, didn't he? They're like marshmallows, aren't
Priestley also didn't believe that he'd discovered oxygen. So he was investing phlogiston. So the reason why things burnt wasn't that they reacted with oxygen, which we now know to be true, and actually his discovery was the one that really turned it. But he thought that, and as did everyone else, that only the things that burnt, they gave off phlogiston, and that went into the air, which was this element that could take phlogiston. And then plants absorbed phlogiston, and they became wood, and then you could burn the wood, and it gave out the phlogiston again. So the idea, what combustion was, what the magic for flame was, if you think about the most magical gas, it's a flame in a way, isn't it? Like, it capturates you. You can look at a fire for ages. And they thought this was a substance, right? And it was this phlogiston that was responsible for the flame of a candle, the flame of a fire. And he came across evidence that it was not. It was an oxygen in the air, and it was the same oxygen that we breathe, and he still disputed it till he died. He said, no, it's phlogiston. And it was other scientists who said, hey, you just don't know how good you are. You really should just take credit for oxygen.
You should do that in a French accent. Is that what you just did there?
Yes, that's right. Yeah, it's like
It was
Lavoisier.
Lavoisier, wasn't it?
Yeah.
Yes,
Yeah.
who named it oxygen and discovered it wasn't just the deflogis. I can't
Yeah,
pronounce that.
deflagenated air.
Deflogistration of air.
What year was this?
It was in late 18th century that, it was the composition of air was discovered.
It was quite remarkably close, isn't it? If you think
Yes.
about, I'm not comparing chemistry with physics here in any sense, but you think that
we were a bit
Oh, no,
behind-
you've really
we were
found out
behind you
things.
guys.
You found out useful things. Yeah, no, well done, chemistry.
Like you, Robin.
Yeah, Newton, 1680s, we have the universal law of gravitation. But it is interesting that the structure of air, atoms, molecules, is a relatively recent.
We didn't have the technology to measure that composition. And now we keep discovering more molecules that are in air. You know, every year goes past, we discover other things. The technology gets better and more sensitive. So
I was going to ask you that, actually, if you give us a breakdown, because it seems like the simplest of things, air, the stuff in this room.
yeah. Well, we know that there's nitrogen. Nitrogen, you know, oxygen around 21%, nitrogen almost all of the rest of it, apart from about 1%. So most of that 1% are the noble gases, and they are...
Sorry about some of those.
So they have very special roles. And then the ones I'm interested in atmospheric chemists are really, really tiny in concentration. So you might have 1 part in a trillion other molecules. And they're so low in concentration because they are so reactive. So, you know, until you can make amazing spectrometers or amazing ways to weigh those gases, you don't know that they're there. We also know there's a lot of interaction with the aerosols that Mark was mentioning earlier, and how those aerosols form, sometimes they do form from gases as well, is a really big question in science and a big question in climate science as well, because those aerosols can form clouds. It's very difficult to condense a vapor if you just have pure water. I think pure water only freezes at something like minus 42 degrees centigrade. It only freezes at 0 because there are other little bits in there that you can't see. So yeah, we are becoming more and more aware, I suppose, of the millions of things that are out there.
I'm just so blown away by the fact that water doesn't freeze at 0. Like, that feels like such a fundamental truth that everyone in this room believed. And everyone's just casually going, yeah, I knew that. Yeah. You bunch of liars. That is mind-blowingly ridiculous.
It's heterogeneous nucleation is the king, where you have another little thing. It goes for aerosols as well, and the droplets condense around something else. They don't like to stick together unless there's something bigger there to stick around.
It was a beautiful thing to watch Dave's face suddenly become totally enlightened when you said heterogeneous nucleation. He just immediately went, oh, of course. So I'm sorry the listeners couldn't see
The thing I
that.
can't get past is also there's these tiny particles of air that's really, really rare that's somewhere in the mix of other gases and things in there that we can't see, perceive, taste, touch, know anything about. But you can make a spectroscope and you can say to me, oh, there's this tiny, tiny proportion of this gas you've never heard of in here. And it's so similar to things on Channel 5 where someone's going, oh, there's evidence a ghost is being in here.
That should work. Oh, I've got my setting all over my chat, so I can't actually see it. Great. Now my controller's not working. Nothing's ever simple, is it? I think it just works. to get up and go to my PC again. Alright. I know why. The window wasn't in focus. I'd just be messing around with OBS, hadn't I? So the window wasn't in focus. Right, how is everything? Am I audible? Am I am I video? Am I human? Am I like that? I was going to adjust the screen. I'm going to do that in a sec. I'm going to get something visible on screen. Oh, my levels are really low. Did that do much? It looks like... Except... Oh, here we go. Okay, the cable wasn't in properly. Good. I can talk without having to plug it in now. Awesome. Talk, what happens to the level? It goes down a little bit. It goes down a bit. That's good. That's what the ducking's meant to do. Okay. Tell me what that's like. Tell me if that's enough. If you can hear me or if you can't. I do feel like it's going to be very funny when it becomes apparent just how much of the game I've got left to play. Right then. Yes. This time will be different. I shouldn't have jumped then. I should not have jumped at that time. But I did, didn't I? Oh, let me actually look at the screen now. I tend to do better when I look at the screen. We did it. We won. We did it. We beat the game. That was it. That's all we had left to do. Genuinely took much longer to get the game running than it did to beat the game. Trans fishers, the best fisher people. Christopher B. Ripping bees. My glasses are a mess. Yeah. Oh dear, oh dear. Belmondo, you played the greatest role in this story. Did I? Me? Stage 19. We can play it again. Have we unlocked hard mode? Are you hard? Why am I ducking? Why am I ducking? Is that part of the new game plus? You duck? Is it duck mode? Duck, duck, goose? There's probably words meant to be in that. Climb the stairs. Ducking again. Jump the back. Oh, these are speed zombies. No, he died. Look at this. These zombies are a lot faster than they were. This is definitely just more than a health diminishing ship. I knew that was going to happen, yet I did it anyway. Well, I think... Oh, we use the select button. Okay. Well, that was Castlevania. I am going to try something a little different now. So, yeah, I'm going to BRB.
I'm literally
basically, there's nothing in my education to tell me the difference between these two things other than my faith in your certificates.
But if somebody sees a ghost, they just say, I've seen a ghost, right? Whereas I can show you some data, you believe it.
Oh, yeah. Can show. Do you know what? The
I'll
number
show
of
you the
times
data.
someone's come on this show and said, I can show you some data. And then we get back to the green room. Oh, I brought the wrong case. Just a load of puzzler magazines again.
But the early investigations of gases are ghost stories. So we all had them. I mean, if you go back to ancient times, the mists that come out, the will-o'-the-wisps in the marshes, these are all ghosts, and they were given names, will-o'-the-wisp, these kind of fairy lights. In every culture in the world, there's a word for will-o'-the-wisp, which is these little lights that appear in marshlands, and we still don't quite understand. We know that the fuel for them is methane coming out of these marshy worlds where there's no oxygen, so you get bacterial anaerobic digestion, as it's called, so you get this kind of digestion of the vegetable matter into methane, and it bubbles up, and it's of course flammable. That's what heats our water in our homes for many of us and gives us central heating, but it sometimes lights, and these gas phenomena people didn't understand. It's like madness. So what do they call? They call them fairies. They call them ghosts. And doors suddenly shutting because we didn't understand about pressure in houses. And so this was further evidence of ghosts. So in fact, we were studying gas phenomena way back. We had lots of names for them, and they're called spirits.
And if you want evidence, Dave, you can light your fart and it will go blue.
Oh, I must have eaten a ghost. I can't believe that. But that is, I mean, Dave, that is an interesting thing, isn't it? Because that difference where we will often see kind of, hucksters and grifters using what appears to be data.
Yes.
And as you said, you can see ghost hunters and they'll kind of go, oh, look, the dial's just gone to very ghostly. But what you're doing, Lucy, that bit of the difference in terms of to help everyone understand the difference when you go, this measurement, how do we know this measurement works? How do we know this is evidence? For instance, you were saying about we're still finding new things in the atmosphere.
Yeah.
Can you just run us through how we are doing that?
I mean, there's multiple different ways of measuring multiple different things. And so it's horses for courses to a certain extent. So mass spectrometry is a brilliant tool because each and every single element or molecule will have its own very specific mass, sometimes down to multiple decimal places. And modern mass spectrometers have got really high resolution, so you can measure something maybe to 6 decimal places in terms of its mass. So it can only be that particular element or molecule. If it's a very complex mixture, so in the atmosphere where it's all very complicated, and sometimes you want to separate things out before you even inject them into your mass spectrometer. So you can do that with chromatography, a very, very old technique, which essentially slows down the path of molecules as they pass down a column. So you can inject things one thing at a time. That makes it simpler. But we're basically measuring the mass of something, and that's a fairly fundamental concept, I think, that most people would believe if they see it. So you'll see patterns in that data that make it very believable.
I do believe you. I do. I just know also I can tell now that the real scientists call it a spectrometer and the ghost hunters call it a spectorometer.